Hello my dear friends, I am Sujoy and today I will tell you how to solve the transportation problem in operations research by a simple method called northwest corner rule or NWCR. Our question is to find the initial basic feasible solution or IBFS of the following transportation problem. This is called a cost matrix and this vertical column is called AI and this number denotes the supply, and this horizontal row is called BJ and this number denotes the demand. Again we have three origins O1, O2 or O3, or we can say three depots or three godowns, and three destinations or three customers D1, D2 and D3. In depot O1 or origin O1 we have total 12 numbers of goods in stock. Similarly, in O2 we have 14 units of goods, and against customer D1 or destination 1 has a demand of 9 units of goods. D2 has a demand of 10 units of goods, and if we allocate or if we transport 1 unit of goods from origin 1 to destination 1, our cost of transportation will be of 5 units. That may be $5 or 5 rupees or 5 euros, anything. So our objective is to transport or allocate goods from 3 origins to 3 destinations in such a manner so that our total cost of transportation will be minimum. So let's proceed to the solution. This is called NWCR or northwest corner rule because according to the map the upside is called north, downside south, right side east and west. So northwest direction will be in this direction. So if we consider this middle element 4 as central element, so our northwest element will be 5, and we will allocate our first allocation to this cell. That's why northwest corner rule. This is the northwest corner. So first we will start with northwest cell or cell 11. 11 means it's in row 1 and column 1, and magnitude of the cell being x11 equals to minimum. So again this cell the total demand is of 9 units and total supply is of 12 units. So we can allocate 9 out of 12 at this cell. So magnitude of the cell is minimum of 9, 12, that is 9. So 9 is allocated to 5. Allocation means writing the allocated value in a small box in that cell. And after allocation 9, so our supply becomes 12 minus 9, 3. After allocating 9, our D1 column, destination D1 becomes 0. So it is exhausted. We won't do any further calculation in this column. So since column D1 is exhausted, we will proceed to the cell 1, 2, means row 1, column 2, this cell, with a supply of 3, along with the row O1. So x12 equals to minimum of 12 minus 3, 12 minus 9, comma 10. 12 minus 9, comma 10. So minimum of 3, comma 10 is 3. So 3 is allocated to this cell of value 1. You can see 3 is allocated at this position. So after allocating this, the O1 becomes exhausted, it becomes 0. But by allocating 3 out of 10, the demand is still 7. We have to fulfill this demand by this supplies 7 and 4. So since row O1 is exhausted, we will proceed to the next row O2 along the column D2 at the cell 2 up 2. So we have demand of 7 and a supply of 14. So we allocate minimum of 7, 14. That is 7 is allocated to at this position, and supply becomes 14 minus 7, 7, and demand becomes 0. So we won't proceed downward along this column since it exhausted. So we will proceed to adjacent cell at this cell. So at this cell the demand is of 11, supply is of 7. So you can allocate minimum of 14 minus 7, 7, comma 11, that is 7. So 7 is allocated at this position. So supply becomes 0 and demand is still 4. So since row O2 is exhausted, so we will proceed to the row O3 along the D3 column at cell 3, 3. That means downward, this position. Row 3, column 3. That meaning of 3, 3. So at 3, 3, we have our demand of 4 and supply of 4. So we can allocate directly 4. So minimum of 11 minus 7, 4, comma, the supply 4 is allocated to this location. So we can conclude that our total allocation is complete, since 9 plus 3 is 12 total allocated, 7 plus 7 14 and 4. Similarly column wise 9, 3 plus 7 10, 7 plus 4 11. So all the demands has become 0, 0, 0. The sum of total demands equals to 0 and sum of total supply also becomes 0. So allocation is complete. The next step is checking number of allocations. Number of allocations are 1, 2, 3, 4, 5. 5 allocations equals to m plus n minus 1. M denotes total number of rows 3 and n denotes total number of rows. It's also 3. So 3 plus 3 6 minus 1. So number of allocations 5 equals to m plus n minus 1. Okay, that means our allocation, our calculation is correct. Next, we have to write this allocation list, which is optional. Our final objective is to find the total cost. So how to write the allocation list? In the 1, 1 location, we have allocated 9. In the row 1, column 2, that is 1, 2 location, we allocated 3. Row 2, column 2, 2, 2 location, we allocated 7. And row 2, column 3, that is 2.3 location, we allocated 7. And third row, third column, 3.3 location, we allocated 4. This is the allocation list. And next, the total cost of allocation is given by the number of units allocated and cost of transportation per unit. So 9 units at the cost of 5 units per 5 rupees per unit. 9 into 4, 9 into 5 plus 3 into 1 plus 7 into 4 plus 7 into 0 plus 4 into 7. That is 104 units. So this is our answer, total cost of allocation 104 units. So friends, this was my tutorial on NWCR method. How was the video? Please let me know in the comment section. I uploaded many other math videos, math tutorials, and many videos on a complete series of tutorials on how to use your scientific calculator for quick problem solving in competitive exams. Many science experiment videos, many videos on computer and technology do-it-yourself, and many electronic projects videos, how to make your electronic projects. So I uploaded all those videos. You can check all them on my YouTube channel. The link is given in the video description. And while you visit my YouTube channel, do not forget to subscribe to my YouTube channel so that you get updates about my latest uploads. I will upload many other videos on operation research, and I also uploaded many math videos already. So by subscribing, you will get an email whenever I upload my next video. So thanks for watching. See you next time.